Let's go through what we did yesterday. Name me something you learnt. What did we do yesterday? What did we cover? What did we cover? Can I please have, let's go Phoebe. What did we cover? We had stationary points. That was exercise 10. Oh, what happened there? Exercise 10C, yes, 10C, which is to do with stationary points. There was only one thing that you needed to know about stationary points and how to do them. What is the one thing that you need to know for stationary points, Daniel? Good, the derivative equals to 0. So the gradient of your tangent line is equal to 0. So f dash of x equals 0. Moving on to 10D. What was it in 10D, Luke?
That's the local maximum, local minimum, local stationary point.
Good. Those are called types of stationary points. Types of stationary points. And yes, we do have 3 of them. We've got local max, local minimum, and point of inflection. What do you have to use to prove whether you have a maximum, minimum, or point of inflection? What do you use, Zan? Good. The table. Now, the sign diagram is what it's called. I mentioned that when you do your sign diagram, what was one thing I want you to make sure that you have to have? You have to have again, Kate.
You have the gradient and then the sloping lines as well.
Fantastic. When you write out your values, most of the time you'll find your stationary point. So let's say it was at 3. You know their derivative equal to 0. When you want to prove whether it's a maximum minimum, you can't just say, if I chose a number less than 3, let's say 1 and 4, you can't just do plus, minus, and then say positive, 0, negative, and then say therefore it's a local maximum. Don't do the plus minus signs. You must use the value. So you have to sub in 1 into your derivative to find out what the value is, what the gradient is at that point, and sub in 4. Okay, so I don't want to see plus and minus when you're doing proving. So if they say state the nature, prove that's a local maximum, show that, or whatever that is, or state the nature, find the nature, whatever it is, anything to do with the type of stationary point, you must do it that way. If they don't ask for it, obviously you don't need to. Yeah, but if they ask you to justify it, you must do something like that. Otherwise, you'll be doing a double derivative. Okay? So that's 10D, and then we're moving into 10E. What was in 10E? What was in 10E? It's just a little quick definition, which is what this question's all about. And the next 2 examples. What was 10E about?
The absolute maximum of the range.
Fantastic. Absolute max and absolute minimum. Just a quick definition of absolute max and minimum. What is that, Jerry? What's absolute max and what's absolute minimum? Yeah, that's it. It's your range. Absolute max is your highest y value, or the maximum range that you have, and absolute minimum is the minimum range that you have. So it's just your y value. So maximum y, minimum y. Yeah, so that's what your 10 is about, and that's what this exercise is about. It's about, they give you the endpoints, -2 to 4, so you've got a restricted domain. You've got a function. Obviously, I always encourage you to picture what the graph looks like, so that you answer the absolute max, absolute minimum correctly. Okay, and that's all it really is. And if it was in an exam, it would be a multiple choice question. It's better to sketch the graph before you answer the question. And that's how they do it. They normally say find the range, or find the minimum, or maximum, or absolute max. And you only get it wrong if you're not sketching it properly. Okay, which we'll do that later. And that's your 10E. We skip 10B, we'll come back to 10B after we do 10E and F. They link together. What was 10A about then? So we started 10A, first session, and then we went in the next session, I did C, D, and E. So what was A about again? Phoenix. Yeah, tangents and normals, that's it. Okay, so I tried to show you that in 10A was literally everything you had to understand about chapter 9, finding out the derivative, but you had to understand that the derivative gives you the gradient of a tangent line. Any tangent line or normal line is given by y equals mx plus c. Your job is just to find out these two. C is easy to find because you need a coordinate, but M was the only skill that you need to use from chapter 9. You've got to find the derivative, and the question is, how do you find the derivative? It could be a chain rule, could be a product rule, could be a quotient rule, could be the derivative of sine, cos, tan, or exponential logs. That's what you have to know from chapter 9 to do that. Okay? Now the only questions that get difficult is when they ask you to find A, B, or C, so extra pronumerals. They don't say just find a tangent line. They say the tangent line is this, and there's a coordinate at A and A squared. Figure out, what A is, something like that. Those are the more difficult questions, but at the end of the day, you're only doing the same steps. You're doing the derivative at a particular point, find the gradient, substitute that same point to find out C. That's it. There's nothing else to 10A. It's the same throughout. Even at the end of the year, you'll be doing this same process. Okay? That's 10A, and then now you got stationary points, types of stationary points. Those are the three. That's how to prove 10E, absolute max, absolute min. Is that easy? Good? All right, let's do this question then. So let's have a look. You got -2 to 4, so I always like to sort of visually quickly picture what I have. So I got -2 to 4, so I say, all right, so let's say -2 is here, and let's say 4 is there. Okay, so I got my domain. I always remind myself, I've got a domain, so these are my endpoints. I've got x squared plus 2. Now x squared plus 2, that just tells me it's a quadratic, and the plus 2 does what? Moves up. Fantastic. Moves up by 2, so my turning point is at 0, 2. Fantastic. So I know the turning point is currently 0, 2. It's a positive quadratic, so I know it must look something like that. And they're both inclusive. Okay, so notice the brackets are inclusive. Okay, so I'm using those circles. So that's roughly my graph. Now, the one thing without drawing the graph, most students in the exam, and if this was a multiple choice question, they'll sub in -2, sub in 4, and they look out for which one's your maximum minimum, right? Well, what can you see as a problem from drawing the graph? Why wouldn't that be correct? What would be wrong?
Because the maximum or minimum is not at any of the endpoints.
Yeah, the maximum is one of the endpoints, but the minimum is not at one of the endpoints. The minimum in this case is obviously 2. Yeah, that's at your lowest turning point, whereas the endpoint here is obviously larger than the turning point. So this is your absolute minimum, but it's also the local minimum, okay? Whereas that is your absolute maximum. So the question is, well, what is that value? And how do you find out that absolute maximum? Because remember, absolute maximum is the greatest y value you have, so how do you find the y value at that point? What do you do? Yes? Yeah, you sub in 4. That's how simple it is. Okay, so it makes sense why a lot of students in the Year 12 exam, why they look at this and think, oh yeah, sub 4 and sub 2 in, because you're used to that. But you got to think about what are you doing. Yeah, and if you draw that picture, it's very obvious why that question shouldn't be done wrong. Yeah, so if you get any students getting it wrong, it's like, well, why are you getting it wrong? It's a very obvious fact, So here we go with sub in 4. If we sub in 4, we get 4 squared, which is 16 plus 2. So absolute maximum is clearly 18. So when they're asking for the maximum, they're not talking about the x value. It's not 4. Your multiple choice questions will have 4. We know it's 18. It's the y value. Okay? And the absolute minimum, which is 2. Fantastic. Y values, not x values. Okay? Is that easy? Try the next one. That's yourself. I'll give you 1 minute. Let's go. Oh, it's a trap.
It's a one-to-one function. Yeah. It's a one-to-one function.
Is it a one-to-one function?
Well, it's just excuse.
You have your CAS, get ready for the next one. You can do it by hand for the next one, but I want you to use your CAS. And 5, 4, 3, 2, 1. Let's go. How do I find my absolute max and absolute minimum in this case? logically, if you can picture the graph in your head already, you would know what you have to do. But what does the graph look like again? Daniel? What does this graph look like? It's kind of like a lighting bulb. Lightning bolt, yes, of course. I was like, light bulb? What does that look like? It was like... Absolutely, no, you're correct. You just use the endpoints. So that's why in these questions here, it's obvious why a lot of students normally just sub in -2 and 1, because if you're doing your exercises, you'll find that most of it you do just sub in. But that's what I'm saying, that the better you understand what you're doing, then you don't memorize, but you get it. Yeah, so there's a difference between getting it and memorizing it, and that's why a lot of students just sub in, and it's wrong. Because yes, you're right. In this case, it does work, because yes, at -2 and at 1, because of this graph, it's clear that the inflection point cannot be the minimum. They have to be -2 and 1. So yeah, this question, just sub in -2 and sub in 1. So at -2, I will have my minimum. -2 becomes -8 plus 2, which is -6. And then at 1, I should have 1 cubed plus 2, which is 3. Okay, so therefore my max has to be at 3, and my minimum has to be at -6. Hands up, you got that correct. Oh, good. Did well. Now, if you have a CAS, use a CAS. If you don't, you can do this by hand. It just takes a bit longer. Okay? Go with this one. I'll help you out by drawing the diagram out. So they tell you you've got a metal sheet that is 2 meters long. Whoops. And they've cut out X amount of squares. So now you've got 4 squares that have been removed. That little X there has been removed. This is a square. 4 squares have been removed. And they fold them, and it becomes a sort of a little box. Okay? Now they're saying in the first question, show that the volume equals this. It's a show question. So in your SACs or in your exams, if it's a show question, you've got to show how it comes about. So you have to imagine that you don't know if that's the answer. How do I get that answer? Okay, you just can't just say therefore it is. Okay, you have to show from what, how do you get the volume of the box. And that's the first step. Volume of the box. Length times width times height. So your job is to find out your length, your width, and your height. That's the hardest part. That's the only hard part of applications, is to form your own equations. Afterwards, it's all easy. All right, let's start off with A first. What is my length, width, and height? Can I please have Jack?
Length is 2 minus 2x, and that's the integral. So it's, and then the height x.
Fantastic. Okay. How do we know this? Again, same thing. We know that the metal sheet was 2 meters long, and that means this is also 2 meters long because it says a square piece of metal. Okay, so if it's squared, that's 2 and that's 2. Now when you're removing the squares, that has a length of x. That also has a length of x. So when you're moving it twice. Because you're removing it twice, it's 2 minus x, which ends up being 2 minus 2x for that length from here to here. Okay? And that means that if you do the same for this side, that will be 2 minus 2x as well. So when you fold it up together, that becomes 2 minus 2x, 2 minus 2x. And that height, that's the height of your shape. That's why we know the height is x. Now you put them all together, we know that the volume has to equal to length, which you said 2 minus 2x, multiplied to 2 minus 2x, multiplied to height, which is x. You can simplify that and write it as 2 minus 2x all squared times x, and if you expand that, that becomes 4. What's that? Minus 8x plus 4x squared times x, and that gives you 4x minus 8x squared plus 4x cubed, which is exactly what we wanted. Okay, that's proving. But you can see how I'm doing it. I started off with your question, the type of method I'm approaching. I had my diagram and I've drawn what the length, width, height is. I've simplified. None of these steps have I made any assumptions. So when you're doing your questions, if they say show or prove or justify, that's the expectation. You can't just go from here and go there. Okay, because they already gave the answer. They know what the answer is. They want to see you take the steps. And this normally happens when it comes to exponential and logs. A lot of students skip the steps, either because they don't know it or because they know it and they skip it. Don't do that. When you're doing show, anything to do show, anything to do justify, you must take all the steps. Five. Okay, so do you need to do the V?
Yeah, like we need a wow. Or you need to use this.
I do that all the time just so that it's clear. I encourage to do that, but I don't know if the examiners will then penalize just because you don't have it, but it's always good to have it to start with an approach and then how you get to your final answer. Okay? Now that's A. So the hardest part was to get A, but even if you, this is one of the tips thing that when you're doing your SACS analysis questions, if you can't do these questions or you get stuck here, it's okay. They gave you the answer, move on with that question. A lot of the times when I'm marking the SACS, I find that students get stuck because they can't make the equation and they're like, nah. And they skip the whole entire question and they move on to the next one. It's great that you're moving on, but you're missing out on all the other ones when they gave you the answer already. So if you can't do A, you might lose a mark or two and move on to the next one. Because you can use this one to do the other ones. That's why it's a show question. They give you show questions because they're scared you can't do the first part, but then they're giving you a chance to do the second part. That's why they do that. So every time you see a show question, most of the time it's the hardest step to get. It's either your algebra or forming an equation, but then that doesn't mean you can't do the others. They give you a show so that you can do the others. So don't skip them. Yeah, just because the first part's hard, don't avoid doing the others. Move on to the next one. You're likely to get marks from it. Okay? All right, now let's say that you got A correct. Let's do B. It says find the value of X that gives the box its maximum volume and show that the volume is the maximum for this value. Most students will get the first step. They won't get that second step because they're not reading. Okay, so when it says show that the volume is a maximum for this value, if you're reading this question here, what are the two things you got to do already? So when I read that, I already see two things that I have to do. What are the two things I have to do? Name me one.
Graphic equation.
Graphic equation is the next step. What does it mean when it says find the value of X that gives the box its maximum volume? How do you find maximum volume? What was that? Why is it dy over dx equals 0? That's a stationary point. Why are we finding stationary points on? finding stationary point. So you're right, that is the first step. dy dx equals 0. Why is that? Yeah, because this graph right now, you're saying sketch volume. So you are partly right that if you sketch the graph, you can see the volume, but that's in the next question. Yeah? This one says volume equals to whatever the x is, whatever that square length that you're taking out is. If you sketch that graph, it's a cubic graph, and it has at some point, and it comes back up or something like that. But this one's your volume, and that's your x. So when they ask for maximum volume has to be something like this. It has to have some point. And then we know that at that point, that's a stationary point. Okay, so that's why as soon as you read these kind of questions, like exercise 10F is to do with this as well, you see maximum volume, you're thinking about, well, is it the maximum of this graph? If this is the maximum of that graph, the first step is find the derivative when it equals 0. That's your stationary point. So step 1, from part B, you should be finding dy dx, or in our case, dv dx equals 0. We want to find the stationary point. But when you find a stationary point, why is it that they need the second part? What's the second part mean? Show that the volume is a maximum for this value. Why do they have that line? So the first step was to find the stationary point. What's the second step?
Because what if it could be a minimum, and that doesn't mean it's not going to make it.
Perfect. See, when we did 10D, we said there are different types of stationary points. So 10C, you found a stationary point, great. But that doesn't mean that that's a maximum. It could be a minimum. Or it could be a point of inflection. We don't know. That is why it says show that the volume is a maximum. And that's the second part that a lot of students will miss out. And sometimes they'll just go, well, it's a maximum. Because they know it's a maximum already. So they're like, it's a maximum. That's not how you answer the question. That's why you lose the marks. Here is where you use 10D, sign diagram that I emphasized. That's what you do there to prove it. Okay? Now, say you can do this on a calculator because it makes it quicker. So I'll quickly show you on the calculator, or you can do it by hand. Find the derivative of 4x cubed minus 8x squared plus 4x. Hopefully by now we can use our power rules. Find the derivative. Let it equal to 0. Now, let's do it on a CAS, and then I'll do it by hand as well. So if you do it on a CAS, I always like to define. And that's the encouragement I always tell you guys to do, especially with analysis questions. I define V as my cubic equation. I define U, you can use any letter you want, I just call it U, as the derivative of V. Okay, so U is the derivative of V, or V dash, and what we want to do is we want to solve for the derivative when it equals to 0. So what I'm doing now, just saying, find the derivative when it equals 0, solve for x. Okay, so when the derivative equals 0, find x. And that's exactly what I'm going to do here. If I was to do it manually, if I were to do it by hand, my answer should be a third and 1. So let's test that. Here we go. dv dx, we know the derivative is 12x squared minus 16x plus 4. True? Okay, so I'm just deriving it. Next thing we know is the derivative has to equal to 0 at the maximum. So I know, okay, dv dx equals 0 at the maximum. So I now got 0 equals 2. I'm going to take out 4 as my common factor. So 4 out, that's 3x squared minus 4x plus 1. And what I can see is I can factorize my quadratic equation. That becomes 3x, x, 1, 3 times 1, minus 1, and minus 1. There you go. So now using null factor law, it's 4 times something has to equal 0. So it's either this is equal to 0 or maybe that's equal to 0. Using null factor law, I can tell that if it was 3x minus 1 to equal to 0, then 3x has to equal to 1, x equals to 1/3. Or you can do this, x minus 1 is equal to 0, x equals 1. Which is exactly what I got up there. Okay, so like I said, you can do it by hand, you can do a CAS. So, but you have to learn both. You have to learn both, especially for your SACs coming up. I prefer that you know how to do it on a CAS. Okay, manually, hopefully by now. I've been training you mostly on manual skills, but I want you to be able to do it with the calculator efficiently too. Okay? But there you go. So you answered the question. You got a third and 1. But what does that mean? What does that mean? I got x equals a third, x equals a 1. What's the point of doing that? I finally got x. So what's 1/3 and 1 tell me? What's 1/3 and 1 tell me again? G? It just tells me stationary points is at third and 1. But the problem is I don't know which one of those is a maximum or a minimum or a point of inflection. So how do I find that out? Which one's the maximum? How do I do it? See, logically I know what the answer is because it's a positive Q graph, so I know it has to be a third, but that's not the point. The point is to show. So how do I show? Yeah, sign diagram. So here we go. Let's do a sign diagram. I'm just going to rub this one out so that we have space to do. Let's do a sign diagram. Here we go. So sign diagram. We've got x, dy dx. Now 1/3, you knew the derivative is 0. Okay, and you also got at 1, derivative is 0. Okay, so you just need to pick any value less than 1/3 or between 1/3 and 1 to find out whether it's a maximum or not. What number would you choose? Less than a third? Which one would make it easy? 0. I would sub in 0. 0. If you sub in 0 into the derivative, which is this one, not that one, this is your derivative, 0 at x equals 0, the gradient has to be 4. Okay, so 4, positive. Okay, what we don't know is whether the next one between 1/3 and 1, whether it's going to be a positive or not. Now, between a third and 1, so 0.33 to 1, what number would you likely use? Yeah, probably do half. Okay, but like I said, these kind of questions, if you did it on a CAS, it's much easier or much quicker. So I'm just going to quickly jump to the CAS. So the nice thing is once you define it, you can just do u of, we did 0 before, we got 4. Now we can do u of 1/2, you get -1. Okay, so that tells me now this must be at half, it's -1, so it's a negative gradient. So you can already say that therefore at x equals 1/3, it is a local maximum, but you're not done yet because we don't know whether that's a maximum as well. We know it's not, but it's just always going to show. Okay, so this is a 0, and then any number after 1, let's say 2, you can do, again, 0, u of 2, that gives you 20, so you know that this is a positive gradient. So therefore, at x equals 1/3, we have a local max. At x equals 1, we have a local minimum. Easy? Okay. Now, having said that, so that's the second part and the third part. That's where most of the marks comes from. So 1, B, and now C, this is where a lot of mistakes come in. So I want you to have a look. They type the equation. So they they've given the equation in part A, and you type the equation into graphing. What's the issue there? But my problem was to sketch the graph of B against X for a suitable domain. That's my problem already. Yeah. X can't be greater than 1, and it can't be less than 0. But this is what happens when students do their SACs. They will type in the equation and like, all right, done. I hope to get a mark because to get the right shape. No, you get 0 marks for that one. It says it's a suitable domain. We only got volume. Remember, it's a volume. You can't have negative volume, so all of this is gone. And once you reach the 0 point, well, that's it. It doesn't come back again. It doesn't make sense. So x is greater than a certain point, or when x equals 2, whatever that point is, which we know is 1, because you already figured it out. You said that the stationary point, that's your maximum, minimum. That has to be 1 then. Okay? So at 1, it doesn't make sense to then continue on because an x greater than 1 will now just change it infinitely large. Okay? And you also know your box dimension has a maximum of 2 as well. So it's limited already. So now we've got up to 1. So what you're meant to sketch is only from here to here. Everything else gets removed. So I'm just going to do a different color in red. That gets removed and none of that should be drawn. So you should only get the blue section there. But be mindful, we know that at 0 and 1, You can't have a volume of 0. You can't have a box with 0 volume. It doesn't make sense. So how do you show that you don't include 0 and 1? Good. Open circle. Okay, and that's what a lot of students miss out on. So yes, it is easy to sketch. Yes, you've got a CAS for all your analytical questions, but you see the level of detail that you have to put in. 0 and 1, and I'm missing the labeling for my maximum. Okay, so my maximum here, which we figured out before, is this 1/3. How do you find the y value? Sub it into which one? So a lot of students will sub it back into the derivative and they get 0, and they're like, all right, 0. Doesn't make sense. It's 1/3, and where do you sub it back in? To v, because that's a graph of v. V by x. So you sub it back here. Sub it into 1/3. So when you go back to your calculator, see the nice thing once you define it is you can just do what v of a third. 16 on 27. Okay, so this is now 1/3, 16, 27. So that's a nice graph. That's how you answer your question for part C. Okay, that's normally 2 or 3 marks. Normally 2, I reckon. 1 for shape and any labeling endpoints and maximums for your second one. Okay. Now the last one, this one normally is an inequality question, and your SACs will be similar as well. There's always going to be an inequality problem. So in this case here, if the height of the box must be less than 0.3, so be careful there, less than 0.3, that is x, which is the x dimension there, is less than or equal to 0.3, what will the maximum volume of the box be? What's the issue here? What is it really asking? A lot of students don't even know what the question's asking. What's the questions are? So if x has to be less than or equal to 0.3, what will be the maximum volume of the box? Yes, Jack?
The x value might be restricted to me. That's not equal to me. And you have y value.
That's literally it. What you just said is the question it's asking. It's saying, in this graph, if the domain is between, in our case, between 0 to 0.3, what is the maximum volume? Now, obviously, the endpoint in this graph here, if you just look at it, at 1/3, actually, I'll draw it over here. See, our graph was like from here, and it comes back up. This is 1/3. Now, 1/3 is a decimal. What is 1/3 as a decimal? Good. 0.33. Oh my God. 0.3333. Now, is that larger or smaller than or equal to 0.3? Larger. 0.333 is technically 33 out of 100. 0.3 is 30 out of 100. So that means that the domain that they're talking about is from 0 all the way to something so close to that, but it's only 0.3. So logically, the maximum volume has to be at where? And how do you find it? Is that x equals 0.3? Sum x equals 0.3 into the volume equation, and you get the maximum volume. But it's not 16 on 27 because a third is bigger than 0.3. So the question was, it's easy to do, but it's the question of, did you understand what the question was asking? Okay. So in our case here, to answer that question, it was just not v of 1/3, but it's v of 0.3. That's my answer. 0.588. Okay, not 16 on 27. How do we feel? Good? All right, I'm going to let you practice with E. F is technically that was just F just now as well. Okay, F is just more problems on the same idea. So we just did a maximum and minimum, and you can have absolute max, absolute minimum problems. But that's F and E. Okay? Now I printed out something for the new, so I'm going to go back to the other side to grab it. I forgot to grab it. But in the meantime, practice 10E. But if you haven't done 10C, 10D, 10E, or 10A, go back. 10A and 10C are the two I want you to do. Okay, so stationary points, tangents and normals, you have to know that. Without that, there's no point doing the SAC. You might as well just quit it. Yeah? It's your bread and butter. It's your bread and butter of the course. So you got to know your chapter 9. You got to be able to apply. All right, I'm going to just run back.